Hi folks, Tom with Heritage here. Today we are fitting a BG/Sync EV charger. Already made myself at home. Okay, so what we're going to do today is we're going to mount a little board here. We're just going to reroute some of these cables. So all these were in trunking. Let's just zoom out a little bit. All this was in surface trunking. So what we're going to do is mount the board here, mount the charger just above it. We're going to go out of the board in either tough sheath cable or HO7 rubber flex. And we've got our 32 amp C32 double pole RCBO type A surge protection, and in the future customer's going to mount some fireproof board here, and we're going to have inverter battery setup. So this is our DC board. So all of our big DC loads, car chargers, solar array and battery are going to be on this DC board, and we're going to come use some tails blocks in the cupboard, which I'll show you in a moment, to keep it separate from the main consumer unit. So here's the main AC board. You can see at the moment tails come straight into the meter. So we've got some tails blocks here. They're going to go into the meter. Tails from the main board into the blocks, and then some 16mm tails through next door. Right, so just fast forward a wee bit. We've got the charger on the wall. You see there we've got my green laser line. So I just wanted to line up the stuffing gland vertically with the stuffing gland, so that the cable run from the board up to supply the charger is just a nice little straight line. Got the board on the wall, nice and straight. Nothing to do with me, this. We'll get all this sorted out. So previously I put a cooker circuit in for these guys. So there was a hole already drilled here, but I've just disconnected the cooker, made that a bit bigger so that I can get my tails. We're using 16mm tails and a 16mm earth. Why not? To supply this board, which is plenty for car charging, potentially charging batteries or discharging batteries. So there might be a fair bit of load at some point, hence 16mm tails. We're coming out of this in 6mm, like I say, either tough sheath cable or HO7. Yeah, so that's where we're up to at the moment. What I also need to do, one of these is a data connection between the main router and the loft. There's a switch in the loft doing some bits, so I need to snip into that. We've got a little network switch, gigabit network switch. I'm going to mount this down here somewhere, because obviously the EV charger needs a data connection, and ultimately the solar PV battery storage setup is going to need a data connection. So we've got in, out, charger, inverter when it eventually gets fitted, and then we've got a spare just in case. Right, so we're just on with rerouting some of these cables that came down along up the other side. Some go into this lighting relay box. We've got a Lutron RA2 select module in there doing outside lights here on a dusk till dawn setting. We had the power going into the panel. So you see I'm going to mount this big long piece of dado trunking along here, just so that there's containment in there for when the inverter and the battery go on at a later date. You just pop out at the top of the dado with maybe some Copex or something to take the cables where they need to be. So yeah, I've just had to disconnect this socket so I can pull these cables out. I'm going to mount the dado trunking, and then I can start to reroute these cables back to where they need to be. One cable literally comes down from the floor above, along, up, through the wall, so I've just had to cut that, and I'm going to take it into this junction box and just joint it. So cut it, pull it back, feed it through the dado trunking into here, joint it. Yeah, a bit of faffing around, but then we'll have a nice big capacity bit of dado on there. Get my tails for the board, down, along and through, all the existing cabling, and then yeah, when the solar PV gear goes in, get an extra circuit out this board, down, along, where it needs to be. So I've got the full length of dado on, so you know, let's just zoom out, when the inverter's mounted up here, battery, etc., we can come out in Copex and just access the connections at the bottom of each unit. Yeah, so just rerouted all the cables through the dado trunking, back through the dado trunking up there. So we've got our cooker cable back through, which I've had to disconnect, pull through, drill a hole for it, feed it back through. So that's going to go in the board. I'll get my tails through that hole as well, fingers crossed. Tails up, you see we've got a knockout at the bottom here. We'll go straight up. We've got a tails clamp here to keep them secured, so that's fine. We've got one of these metal P-clips. It's only a really short vertical run there, but just to keep the cable secure, keep it out of the way. So that's where we're up to. Let's get the lids back on the mini trunk in there. Just need to cut them down like I did. You know, they did go all the way to the floor. You can see there before. Just chop that off so that we can get the dado in. So we'll get the lids cut down, get that back on. You see, there's the cable that I had to chop into. So it was the right length before, whereas there's one end, there's another end. So I'll just need to sort of link that out inside the box. We're not doing that in the trunking. There's actually eFix did a video on it as to whether it's permitted to use like Wago connectors or similar in here or in the dado, which turns out it isn't. So we're doing the joints in a dedicated joint box here, which is used, like I say, for this Lutron RA2 module, but we're just piggybacking off that to do those joints. So let's just get everything neatened up. So we've got the trunking lids back on, and then there's the new bit of dado in. So we've got our tails going into the board. This is going to be our charger. This is our supply for a surge protection. So coming to the end of the day now, we're just doing the connections for the charger. So we'll just put a RJ45 on. We're just going to mount a little switch down here. We'll just drill this out the bottom. Keep it nice and neat. Get an end cap on that, on the other end. Yeah, so we're getting there. You see, we just clip that back to the wall with the Cat 6 cable. So we'll just try and find some neat way of getting this down to the switch. This is obviously the tethered lead which wraps around, so we're just going to tidy up, get the cover on this so the rest of the electronics don't get damaged. So this is the cover. You can see from the size of my hand it's a really small little unit. There's the inner guts. So we've got, I think that's for a current transformer. If you need to take a look at, I think it's dynamic load switching, so it just sort of manages the load. In other words, if there's high demand on the house, you know, this can sort of throttle the amount of current being pulled for charging. What else have we got? There's the data connection that I've just made a cable off for. We've got the incoming supply there, which again, just put the plug on the other end of that, and then that's out to the tethered lead on the outgoing side of the RCD. Right, just a quick update. So I think this comes with 7.5 meters worth of charging cable, which is bloody miles. So, you know, you can wrap it around here, and then it comes with a wall mounted little attachment, because otherwise it tends to do that. So that's quite a handy little thing just to keep your cable tidy. So yeah, that's nice and neat. Cut into the data cable that comes from the router in the house, goes up into the loft space, and you can see I've just routed it in the trunking, and I could do that because even though there's twin and earth run in the trunking, this is shielded cable, so it's shielded to protect against any sort of electromagnetic interference. So I've just run that in there, put a little stuffing gland in, compression gland, so that I can jump back into the trunking to come along when the solar goes in. And then just sort of, you see we've got the charger data cable just drops straight in there. Just need to get a clip in there or something just to hold it in place. And then rerouted the bell box cable, just try to keep, you know, straight lines wherever possible, just keep it neat. There's a lot of cabling going on that wall, but it's all sort of a bit of a mishmash of various contractors and stuff. I don't want to start you know, trying to reroute this and neaten it up. It'd take ages, and you know, a little bit of a pain in the bum. So right, so we've just got some power onto this board. We've got the supply coming in from the tail blocks, so we're going to go through, make sure we've got an R1 plus R2 measurement, insulation resistance for the car charger. We do a ZS dB test, so essentially a ZE. In fact, it's coming off the main tail, so before we juice this up, disconnect the earth, get a ZE measurement, connect it back up, get the fault current measurement, line to neutral and line to earth, do our dead tests, do an RCD test, and then we're ready to juice this up and register it with the DNO, get it all set up, do a little handover for the customer. So we've just done measurement of ZE, where we disconnect the earth, clamp around that, one crocodile clip around that, and then probe onto the line. So that's given us 0.34. It's TNCS system, so maximum value quoted by the DNO is 0.35, so we're just within that. We then reconnect that back up to the board, and we do a fault current measurement. So we do probe onto line and neutral, take one reading, and then a separate reading line to the earth bar. Sorry, brain fart there. And then we take the highest value just to make sure that the protected devices downstream are capable of interrupting super high fault currents, but in this case they're well within, you see, 6,000 amps. Fault current here is about 600. So then just had a quick thought. So we've got a 1361 fuse protecting the the tails. So we've not used 25mm tails, we've just used 16mm tails here because, you know, we've got a 32 amp car charger, and then we're going to have a solar array, which might just take us over the capacity for 10mm tails, so we've bumped it up to 16 just in case. Nevertheless, just wanted to do a couple of calculations, make sure that these tails are protected against fault current. So we'll just go to the regs, and we're using the adiabatic equation here. A combination of that, and towards the back we've got time current characteristics of different protected devices somewhere. Where are we here? Yeah, so here's an example of a page, some fuses. So we plug in our fault current down the left hand side here. We find whichever fuse we're using, and then we work out how long it takes for that fuse to trip, or fuse. And in this instance, the fault current gives us a fusing time of around about 3 seconds. So we then plug that into the adiabatic equation. So we've got time, we've got a constant depending on what type of cable we use, we've got the cross-sectional area of the cable, and then we've got the fault current. So if we rearrange that, then we can ascertain that if it takes 3 seconds to trip, fault current's a certain value, that's a constant, it will then throw us out a cable size required to carry that fault current for the duration needed before that fuse fuses. And in this case 16mm tails are more than adequate to carry the fault current for the amount of time required for that fuse to trip if there is a fault. So I'm happy with using 16mm tails. So it's just a bit of an afterthought. So the actual individual circuits, you know, these are good for give or take about 80 amps maybe. I need to just go in the good book to get an exact value for that, but they're good for about 80 amps. The two circuits that we're going to be having are not going to be pulling anywhere near that, but so that's fine. So you know, the cable is not going to be overloaded. I just wanted to check if there is a fault sort of upstream from this board. So in other words, between the tail blocks and here, which is literally 1 brick's distance through there, so it's not even 2 meters. But just, yeah, belt and braces, make sure that that cable is protected if there is a fault between the tail blocks and here. Right, so just temporarily linked out line and well, just temporarily linked it out with the earth bar to do our R1, R2 measurement. Took the cover off. Obviously it's negligible, some meters coming back as 0 because it's a tiny run of quite chunky cable between there and there. So 0.01 essentially. So if we go 0.34 add 0.01, that gives us the ZS of 0.35, which is well within what it needs to be. You can see there 0.68. So if there is a fault current on there, it's going to trip the breaker in easily enough time to meet our disconnection times. Right, so we've just done our RCD test without the load connected, so I left the line out. So we've got our RCD test has passed, so we've done all our tests, and now we go through the commissioning process, and yeah, notification of the DNO. So this means that it's either waiting for network settings to be applied, or we've just applied some network settings, so in a moment this should turn blue, meaning that the charger's online and we can carry on with the commissioning process. Let's just give it a moment. Right, so you see we're just given that a minute, it's updated, it's now got the solid blue line as opposed to the yellow, so it's got a network connection. You can see that data transfer, We've just gone on to complete the commissioning process. So you need to punch in essentially the identification or serial number with this. It will then allow you to see that it's online. As an installer, you then put in the customer's details, and then the customer can then download the sort of consumer app, which allows you to do some fancy stuff. So it can function as a dumb charger. You can just plug it in and it starts charging. But for any of the like delayed charging or load management or any of the analytics, you'd need to download the app and to make use of that. And there we go. So that is the Sync EV charger. Thanks for watching. Don't forget to hit like and subscribe.